Hi everyone, this is Asma Mushtaq from DW Vibes, and in this tutorial I'm going to guide you how you can generate square waveform with the 50% duty cycle on the PIC microcontroller on the MPLAB simulator. Okay, and for that, since I'm going to generate the square waveform on the 0 pin or the first pin of the port B, with the 50% duty cycle. By the 50% duty cycle, we mean that for the equal amount of time, the waveform will be on and off. Fine. So, what I have done first, I have made the pin 0 as an output pin, and then I just set this pin using the command set file register port b comma 0. Then I called certain delay routine, and then I cleared the 0 pin and then call the delay routine, and then we loop back basically because we want to generate the waveform continuously, and here is the delay routine written. Okay, now let's see when you will debug the program. And since I have already debugged this program and there are no errors present, I will just import the hex file into the PIC microcontroller on the Proteus. So let's go there and let's just zoom a little so that we can see it better. Then the next step is to provide the path of the hex file to this PIC microcontroller, and after that you just need to click OK. Now, in order to visualize the output waveform on the pin 0 of port B, what I need to do, we will go to the meters and measurement tools, and from here you will select the oscilloscope. Okay, and then you will place it here. uh, here are 4 channels available on this oscilloscope, and you can use any of these. I'm using channel A for the waveform, and let's see what happens when you will play this circuitry. And you can see clearly here 50% duty cycle waveform is generated. Now let's vary the duty cycles and check either they work or not. So I'll pause it and I'll go to my original program. In order to generate the 75% duty cycle, where I have set the file register, I'll call the delay routine thrice. So it means 3 times I am making it on and only 1 time I am making it off. And in this way, I'll get the duty cycle of 75%. Let's see how it works. So it has been simulated properly. I'll provide the path to this hex file again, and I'll see whether it works or not. So let's just simulate it, and now you can see here the waveform is on for 3 by 4 part of the time period, and only it is off for only 1 over 4 part of the time period. Similarly, you can make changes and see how the output actually varies. So in order to generate the output waveform of 66% duty cycle, I will just call the delay routine twice, and I will keep it off for only 1 time. Okay, let's just do it. And by varying the delay routines, you can see how the output waveform is actually changing. In this way, you can generate the output waveforms for the different duty cycles. If you have some questions, you can drop your queries in the comment section. Thank you for watching.